Well, good evening, everybody. Welcome to our technical webinar series. I am Lori Schiavo, the Senior Director of Operations here at RSES. And I just wanted to welcome everyone to tonight's session, which is being presented by Nick Agopian. And his session is titled Addressing Critical IAQ Challenges. For those of you who don't know Nick, he is president of Reviveaire, which specializes in enhancing IAQ in residential spaces, commercial airports, and educational and healthcare facilities of all sizes. He's a 40-year veteran of the HVAC industry. He holds a building systems engineering degree from Vanier College and an MBA from Duke University. And he's also a member of ASHRAE SPC 62.1 and 62.2, which is Ventilation for Acceptable Indoor Air Quality Committee. He's also part of ASHRAE TC 2.3, Gaseous Air Contaminants and Gas Contaminant Removal Equipment, and ASHRAE SPC 145 and other committees. As always, tonight's presentation is being recorded. It will be about 45 minutes, and then afterward I will open up for questions and answers. You can ask your questions by using the question tab, which is on the top of your screen monitor there, and then I will field those aloud to Nick. This presentation will be available as soon as possible in our archives as well. And I think that's all my housekeeping. So I'm going to go ahead and turn it over to Mr. Nick Agopian.
Thank you so much, Lori. I really appreciate it. So as mentioned, I've my entire career focused on indoor air quality, and whether it's on the filtration side or whether it's on the ventilation side, it's about improving the human condition indoors. Lori, can you confirm that you're seeing my presentation?
I can. It looks wonderful.
Thank you. So what we're going to be talking about is indoor air quality when it pertains to pathogen disinfection and particulate control. I'm going to talk about some of the technologies that are out there. But before I get into that, I also want to put on my ASHRAE hat and talk about what's going on at ASHRAE now that it's post-pandemic. If we go back 10 years ago or even longer, ASHRAE recommends a minimum MERV rating in the HVAC products. And most of the time that was just to protect the cooling coils and to protect the HVAC system without any regard towards human health. Today, post-pandemic, ASHRAE is shifting to becoming more of a health standard than not. And some of the things that we're doing at ASHRAE that's going to be put into standards and adopted by code is things like DALY, which is Disability Adjusted Life Year. This was a 10-year study funded by the World Health Organization and the Gates Foundation that tried to understand how do we live our lives from when we're young, as you see here, and we have an incident, we continue our lives, we have an incident, we get to being young adults and have an incident. You can see our lives get shorter and shorter and shorter when we don't have incidences. Then we live with disability and die young. And so trying to understand why that happens, they looked at 75 different reasons. That starts from high blood pressure, tobacco smoke, alcohol use, low diet in fruit, a whole bunch of different medical reasons. But two of the top 10 reasons besides those other medical reasons is indoor air quality. And LBNL, Lawrence Berkeley National Lab, back in 2011, identified all of these reasons at why we have issues. The top four being PM 2.5, and that's particle matter 2.5 micron, secondhand smoke, formaldehyde, and acrolein comes from secondhand smoke. Now, when it comes to firsthand smoke and secondhand smoke, we don't necessarily smoke indoors as much anymore. And when we look at formaldehyde compared to like 20 and 25, 30 years ago when we had formaldehyde in everything, today we limit the amount of formaldehyde that ends up in our supply chain. So out of the top four reasons, particle matter was identified as being a huge concern. Earlier this year, or I should say earlier in 2023, the University of Nottingham tried to understand harm. Okay, so we say particles are a problem, formaldehyde's a problem, NO2 is a problem, and radon's a problem, but what does that mean? And so we need to compare that and apply a harm number based on DALI. So just to understand why particles are important in our designs, we try to reference them against alcoholism, smoking, and transport industry. Injuries, I should say. Now, not getting into details on what these numbers are, and if anyone's interested, they can get back to me offline and we can talk about the details of this. But as a number, the number of deaths due to alcoholism is 1,200. Number of deaths due to smoking is 2,600. Number of DALI deaths caused by transport injuries, which is everything from planes, trains, automobiles, motorcycles, bicycles, whatever, boats, whatever the case may be, is 1,000, and that's the lowest number. So now let's take a look at what we're exposed to, which is particle matter 2.5 micron, particle matter 10 to 2.5 micron, NO2, formaldehyde, and even radon. And radon is very well known and is problematic in many of the states, and ozone. And even though we know radon is problematic and is second to cigarette smoking when it comes to lung cancer, look at this number, 34. Particle matter 2.5, 1,600. Almost like, if we look at before, almost like cigarette smoking, more than alcohol and transport injuries. So particle matter is the number one cause of concern when it comes to the built environment. And when we compare them all together and we add fine particle matter with coarse particle matter, that's 2.5 micron all the way to 10 micron, and you add 66% to the 13%, we're at almost 80%. Formaldehyde, radon, ozone, NO2, and NOx basically is just a fraction of what this is. So one of the things that we're doing at ASHRAE is looking at increasing the minimum MERV rating that goes into HVAC systems. And it's out for public review as we speak, to take your typical MERV 8 and bring it up to either MERV 13, but the goal is to, minimum MERV 11, I should say, and the goal is to get up to MERV 13. And in fact, if there are any listeners from California, you already know that under Title 24, if you have a certain distance from a highway, you have to, by code, use minimum MERV 13. So what does this mean? Let's try to visualize what these particles are. And here's fine beach sand and one strand of hair. So this is one strand of hair, and the blue dot on one strand of hair is this big PM10. And right beside it is one red blood cell. The red dot on the blue dot on one strand of hair is this little PM2.5, which is basically a quarter of a size to a third of a size of one red blood cell. And then, of course, you got bacteria and viruses that are even smaller in PM1, which is like a virus. And wildfire smoke is somewhere in between PM1 and PM2.5. Now, unless you've got like MERV 13 and better filtration, you've seen PM2.5. Think about waking up at 10 o'clock in the morning on a Sunday morning. The sun just happens to be coming in at the right angle, and you see all that stuff that's floating in the air because of the reflection of the sunshine. Where the sun rays end, you don't see it anymore. It disappears. Well, that is PM2.5 and PM1 and PM2 and PM0.5. It's always floating. It's never settling like PM10 so that you see like the dust on your desk or your computer screen or on your floors. It stays floating and moves in a Brownian movement and is always around the breathing zone of occupants indoors. Now, why is it important? When we take a look at our bodies and we look at our lungs, deep down our lungs, we have the air side and we have the fluid side, like a cooling coil in an HVAC system. Air side, fluid side. The fluid side is blood. And those pockets is where we exchange CO2 and bring in oxygen. This barrier that you have here is 0.1 to 2 micrometers. And one skin cell is 30. So this is very, very thin. So it's the kind of thing, what happens in Vegas stays in Vegas. Well, what ends up in your lungs stays in your lungs, and it ends up in your bloodstream. And that's critical. And PM2.5 being a particle, once it ends up in your blood, it thickens your blood. So your heart's a pump. And as you thicken your blood, your heart has to pump harder. And in fact, the Institute of Medicine has deemed PM2.5 a promoter of heart attacks and strokes. because once it's in your blood, it's like triglycerides. It's like a little particle that's in your blood, thickening your blood. And triglycerides come from cheese and alcohol. So you're just increasing the problem. And right now, they're trying to understand the stem of Alzheimer's because they feel that fine, ultrafines or fine particle matter will penetrate the blood-brain barrier and is being studied as we speak. It's not like, the Institute of Medicine saying, okay, these are promoter of heart attacks and strokes, but it is suspect for Alzheimer's. So dust in itself, when my mother used to say, Nick, you got to dust your room, I always say, okay, mom, okay, mom. Well, she was right. Dust is extremely problematic. Now, if I just take 10 micrograms per cubic meter of PM2.5, and this is a study that was presented in March of this year by the World Health Organization, I would ask the audience, is it 5% of the population that's affected? Is it 10% or 15%? It's a whopping 34%. And I don't know if you all noticed when we first started the presentation, I've got some, gray hair, and I kind of, Lori, aged myself, but with the amount of time I've spent in the HVAC industry. But when I was younger, I never saw anybody with a puffer. Today, a third of the people have puffers walking around because of issues associated to asthma. And that stems from particle matter because as it ends up in our lungs, it inflames those little tubes that causes people to have that wheezing sound when they're trying to breathe. Now, when it comes to HVAC systems and the ducts themselves, that's where the problem starts because we're distributing everything within the built environment through the ductwork. So what happens in one space ends up in another space. Now, this could be cooking in the kitchen. It ends up in the living room. This could be a boardroom where you can have somebody that's infected with or has a cold and will distribute the influenza virus to other places. So looking at advanced filtration systems so that we can confine what happens in one space and not have the HVAC system distributed to other places. Now, a lot of people don't realize that back in January of 2023, while we were still in the pandemic, ASHRAE received a letter from the administration, the White House, that said you've got 6 months to come up with a standard. So as an organization, we sent back a letter to the administration saying, thank you very much. We understand the problem. We're on it, but it takes 2 years to write a standard and then 2 years to get adopted by code. And this was during the first day of the 6-day technical conference at ASHRAE. And we sent the letter on the second day. On the third day, we received a representative from the White House that said, listen, this is not a code issue. This is a national health security risk. And you got 6 months to come up with a new standard or the administration will not lift the pandemic restrictions. I wasn't on the main committee. I was more on the sidelines. I was looking at everything that was going on. But they came up with the standard. It went up for public review. It had over 1,000 comments. Everything was answered, and then it was voted into a standard in the summer meeting. And then around August, when it went back to the White House, then and only then, and I think it was 4 to 6 weeks later, the pandemic was lifted. But this standard is standard 241, and it's labeled the control of infectious aerosols within the built environment. And it gives you two options to protect people indoors, either ventilation or filtration. Now, when you're going to be looking at ventilation, and you've heard this throughout the whole pandemic, open your windows, open your doors, open up your outdoor air dampers, bring in as much ventilation. Because what we realized is that the potential of a person being infected is based on two factors. Either number one, the concentration of the pathogen, or number two, time. So if you can control any one of those two, you're able to protect people. So obviously the concentration is the best way to protect people because we can't tell them you can only spend 10 minutes in a room as an example. So ventilation meant that you have to take your typical 15 CFM or 20 CFM per person and bring it up to like 50 and above. So it becomes expensive and you can't operate that all the time. So you're on standby. The alternate method, which is the filtration method and the more preferred method so that you can conform to the energy standards, is putting in some kind of advanced filtration, either putting in like MERV 16 filters or MERV 13 filters, otherwise electronic filtration like ionization or UV lights, or what I'm going to be talking about a little bit later, which is plasma filtration. However, if you're going to do that, you need to look at 4 considerations. Number 1, you can't use a single pass duct, and it has to be an AHAM chamber tested device. And this is interesting. The reason, and this is probably going to shock everybody, when you buy a MERV 13 filter, you're not getting a MERV 13 filter. And here's why. For those of you who have kids, or when you were growing up, you could take a balloon, blow it up, and then tie it up and then rub it against your clothes or a sweater, or rub it against your hair, and you could stick it on the wall. That's called static electricity. So there's a static charge. Well, filter companies do that. And when they tested against 52.2, which is a single pass duct, for whatever it is, 20 minutes or a half an hour, the static charge remains there. But you know, if you put up that balloon on the wall for your kid's party, in a day that static charge is lost. Well, the same thing with filters. So the best day of a MERV 13 filter's life is day 1. From then on, within a day or two, it drops, and it could drop to MERV 10 or MERV 11, and then comes back up again. Some of them never even hit MERV 13. So today, we're asking people that if you want to buy a MERV 13 filter and you want to get it tested, you can't have the static charge on it, which means that if you want a MERV 13 that's a real MERV 13, you have to ask for a MERV 13A, which is actual, or MERV 11A. Number 2, you can't test using SARS, because now we know SARS is actually quite weak. You know, we said you got to use bleach and ammonia to scrub surfaces. Actually, if you take a damp cloth and just wipe it, it renders the virus ineffective. So you have to test against something called MS2, which is bacteriophage, and it's very difficult to remove. Thirdly, you can't have any byproducts from your device. And lastly, you can't produce ozone. So obviously, if you put in MERV 16 filters, none of this is a concern, but you do got to test it against MS2. If you are using electronic devices, then these have to be complied to. So what do? You know, what technologies do we have available for us? And we've got obviously UV lights, you've got photocatalytic oxidation, ionization systems, and hydrogen peroxide. And then lastly, something called non-thermal plasma air purification. And we're going to talk about all 5 of these on the good, bad, and ugly, and whatever. So let's talk about needle point ionization, bipolar ionization. It's a proven technology. It works. There's a lot of testing out there on the efficacy. However, one concern, or a lot of people's concerns they have, is that the ionization and the reaction occurs within the space. And a lot of people are concerned because if this reaction is occurring within the space, it's occurring around the breathing zone of people. But at the end of the day, ionization is something that has been operationalized and works. But there are organizations like the EPA that say you have to be concerned to make sure that you're designing the ionization system, that it doesn't generate ozone and it doesn't generate harmful byproducts. So that's a concern. And in fact, it's not only on ionization, it's on everything that's out there. Photocatalytic oxidation, which honestly, I love. I think it's a great technology. But again, it has to be designed correctly, where your UV light intensity has to match the amount or surface area of titanium dioxide. If it's designed correctly, then you're able to take the contaminant all the way to something that's non-toxic, where you're generating CO2 and water. So that's why I think it's an amazing technology. But if it isn't designed correctly, you can generate a toxic contaminant. And in fact, Concordia University in 2015 came up with a study on it. And in their conclusion, they wrote, imagine if in an effort to clean air more efficiently, you were involuntarily introducing chemicals more dangerous than the ones you were trying to scrub. So when you're designing photocatalytic oxidation systems, it's important that you're working with your supplier and making sure that it's designed for the application. Hydrogen peroxide. Great technology, but really you can't have that in general offices or in daycare centers. It's great for surgical suites when there's nobody in there. But there isn't that much data out there on on what happens to people. But we do know that hydrogen peroxide is corrosive to skin, eyes, and mucous membranes. Which leaves us with UV light. And UV lights, again, a proven technology. It works, but it's got to be designed correctly. And you got to make sure that you design it so that you take into consideration the degradation of the UV light, which means, and there's so many different types of UV lights out there. Some of them degrade faster than others. So, for example, if you've got a light that you know is going to degrade in a year by 10% or 20% or even 30%, it doesn't matter, then you got to divide by 0.9 or 0.8 or 0.7 and increase the intensity to take into consideration that degradation. And one of the reasons is because doctors are saying, hey, be careful that you don't end up just not giving the full effect of either killing a bacteria that's DNA based or rendering an RNA based virus ineffective. Because if all you've done is lowered the UV light intensity where it's not killing it, all you've done is just pissed it off. And it's going to come back stronger, and it's going to make it even harder for the UV light to control it. So when you're looking at a guy like this who has a UV light in the duct and is very happy, he says, "Oh, I'm protected." Actually, not necessarily. When you look at UV light, scientists have shown that you need about 75 millijoules per centimeter square in order to give you the kill of 99.9%. And when you look at some of the different UV lights out there, the average is about 6 watts. And with 6 watts of power, you only need 0.35 seconds of residence time. So 0.35 seconds, you say, oh, that's a third of a second. That's a blink of an eye. Well, again, you have to be careful because UV lights work. They're a great product, but when you reverse engineer it and you have 500 feet per minute in an HVAC system, 0.35 seconds equates to about 3 feet of illumination. So again, if it's designed correctly and applied correctly, they work, but you got to just make sure that you're designing it and make it applicable for the application. And if you're going to put it in a duct where it's 1,000 feet per minute, now at that point you need 6 feet of illumination. So again, designing something correctly is going to be paramount. And just as a concern, now I'm presenting this, I haven't studied this in its fullest intensity or in its fullest detail, but I just saw this study. It's a new study on UV influences. And I was quite surprised that UV lights do generate ozone. They do have some byproducts and they do generate ultrafines. And whoever's interested in this study, I'd be more than happy to send it out to them. But as a caution, I was listening to a presentation yesterday in Australia where they were talking about some of the concerns with UV lights. And I also listened to another presentation yesterday by Bill Benefleff from ASHRAE, who also said, there are some concerns and we just got to watch out on what's happening from UV lights. And then finally, this latest technology that's out in the market, which is a plasma technology, and it seems to be an emerging technology that's quite interesting that I'd like to talk about. Everyone's familiar with the 3 states of matter. You've got solid, liquid, and gas. And if this was H2O, being water, when it's really cold, it's ice. And this is where the molecules are stuck together and they don't move. You add a little bit of energy, now becomes liquid water. The molecules are still stuck together, but they can move freely. Add a little bit more energy, now you have a gas. And these molecules are floating all over the place. That's what you call humidity or vapor. You add a little bit more energy, now you're in something called plasma state. And a lot of people say, what exactly is plasma state? Well, 99% of the visible matter in the universe is actually in plasma state. Now, there are 2 forms of plasma. You've got hot plasma, which is like a lightning bolt or an arc welder or sparks and flames. But then you've got cold plasma. And when you take a look, I mean, a lot of you must have seen this novelty ball. If you touch your finger here at this point, well, the lightning bolt is going to touch your finger. And you can move your finger and that arc will just follow your finger. And a lot of people think, oh, it just stops there. Well, this is actually somebody here that took a fluorescent light bulb. You can see it's unplugged. When you bring it close to this bulb, the fluorescent light bulb illuminates. So there is a plasma field that's surrounding this thing that causes this illumination to occur. So with some of the plasma technology that's out there, what they do is they take regular line voltage, that could be 120, it could be 220 volts, and they bring it up to 5,000 volts or 5,500 volts and higher. And they're creating this plasma field within spaces. Now, what's interesting about this technology, like other technologies that emit stuff in the air, this is confined. And what's interesting is that it's not trying to go and kill the pathogen, because all pathogens have a body, as you see here, with receptors on the outside. And this body encapsulates the genetic material of that pathogen. In the case of something that's living, like bacteria or mold, it's got DNA. In the case of a virus that's not living, it's got RNA. And what plasma fields do is simply create a lesion to expose the genetic material on this fatty tissue or this body, and then expose it to atmospheric oxygen, leading to oxidative damage. So in the case of DNA, again, it kills the DNA. In the case of RNA, it renders it non-effective. And what's interesting is that when you look at some of the tests against SARS, it's got an incredible 99.9% reduction. Even when it mutates to Omicron, you've got the same reaction. Now, as I said earlier, ASHRAE says, no. You can't use SARS because it's too easy. When you test, now in this particular case, we tested ours, and we found that the equivalent removal efficiency was 97.2 or 97.8%, because again, MS2 is a lot harder to remove. And unlike some of the other technologies, plasma systems don't generate ozone, at least not when you design it correctly. Again, like everything else, like we said about UV lights and ionization, you have to be careful and work with the manufacturers that you have to make sure that it's applied correctly, that you're not putting too much voltage to the point where you're going to make ozone. But under normal conditions, plasma technologies don't generate ozone. And this 2.3 ppb that was reported out by the laboratory was just background ozone. But even if it was generated by the technology, it's still well below the ASHRAE guideline of the UL 2998 limit of 5 ppb. Now, what's really interesting is in the ASHRAE journal in December 2023, there was an Australian university that published this article about airborne particulate matter filtration using non-thermal plasma. And they looked at the composition of air. And to my surprise, actually, when you look at the composition of air, you got 0.3 to 3 micron, which was pretty much 90+% of all of the contaminants or the dust that's in the air. Because 5 micron or all the way to 10 micron and above 10 microns, well, that typically settles out. That's the stuff that we talked about earlier that ends up on your desks and ends up on your computer screens. But the stuff that stays airborne is truly the PM 2.5 and smaller. If you remember, I told you with that ray of sunshine, when you're waking up in the morning, it's always moving in a Brownian movement. So those are the contaminants that we should be watching out for. But when you take a look at the data here, the green bar shows what a MERV13 filter would do. The blue bar is what non-thermal plasma would do. The red bar is when you combine the technology together. So I find that very interesting, and I wanted to try to replicate it in a laboratory in Minneapolis. And to my surprise, I saw the same thing. This would be a MERV8. This would be a MERV13. This is the non-thermal plasma system. And then when you combine it with a MERV8, you see this kind of a response. So like what we saw earlier, as these ions are floating around, you create an agglomeration that occurs of these submicron particles or ultrafines. And this doesn't only occur with non-thermal plasma, but ionization and bipolar ionization, like needlepoint ionization with bipolar ionization, does the same thing, which is a fabulous phenomena that occurs. Because as I said earlier, these ultrafines and submicron particles are truly the greatest threat to the physiological operation of the human body. That's whether it's on the organs or whether it's in brain function or cognitive function. So the ionization technology and the non-thermal plasma technology both will give you this kind of phenomena, which I think is really critical and quite important. And when we take a look at biofilms on cooling coils, which constitutes to 30% reduction, or sorry, 30% increase in cooling mode, is something that needs to be looked at. So all three technologies, whether you're using UV lights or whether you're using ionization or whether you're using non-thermal plasma, will help you to control biofilm formation on cooling coils. Not only is it important for consideration of energy conservation, but it's also achieving dew point conditions, because you lose your dew point condition when you have these kind of biofilms that are forming. But more importantly, they generate microtoxins, which again further complicates the indoor air quality equation by emitting these microtoxins in this space. But as I said earlier, whether you're using ionization or UV lights or non-thermal plasma, all three technologies will be able to afford you the potential of controlling biofilms. And biofilms is truly something that we should be taking into consideration in every single HVAC design. And when we're talking about ionization or non-thermal plasma in this particle agglomeration, I think is something that we should all be entertaining. Here's a study that's ongoing right now in New York City over at the Lincoln Center. And I don't know, for those of you that don't know, the Lincoln Center is huge. Like, this is the Lincoln Center, this is part of the Lincoln Center, back there, and even here, which houses the Juilliard School of Arts. One of the systems, AHU7, had MERV 13 filters followed by MERV 16 filters in order to protect people that come into there. And of course, you have all these people that are sitting shoulder to shoulder. So you want to make sure that the air is clean. And in this particular case, it was more for pathogen control, but also for particulate control. But the primary was for pathogen control. And because ionization systems and non-thermal plasma can agglomerate particles, you can remove the MERV 16 filter and take this MERV 13 that was the pre-filter and put it to where the MERV 16 was. And then in this particular case, they're installing the non-thermal plasma where the MERV 13 filter is. Now, the test is underway, but the modeling has showed that when you calculate the energy cost over 10 years, compared to, again, this is non-thermal plasma, but the same thing could be done with ionization, you'll see that the costs are tremendously different. A MERV 16 filter over 10 years will cost you, based on this data, almost $100,000 in electrical costs compared to $9,000. And I believe if you looked at ionization, it might even be less than that, but I'm not sure. Why is this important? Because the payback is less than 1 year. And even if you only had a MERV 13 filter that you now use a MERV 8, the payback is anywhere between 2 to 3.7 years. So with these types of technologies, you can agglomerate and then at that point reduce the MERV level of filtration that you have, but yet still achieve the higher level. So not only if you are using MERV 13s to control, and again, you should be looking at MERV 13A to control potential pathogens in the space, or if it's just to control ultrafines within the space, you can downgrade that down to a MERV 8 and still achieve the same type of condition. So there is a payback that can be taken into consideration. So you're looking at pathogen control, you're looking at particulate control, you're looking at biofilm control, and all this can come back with a payback, at least with these two technologies, whether it's non-thermal plasma or ionization. And again, at least for non-thermal plasma, I can talk about this, but if you are considering ionization, you can speak to your manufacturer and see what they can offer. But I'm sure they can give you the same kind of benefit analysis. You know, applications to these kind of technologies is, of course, looking at in this case, it's a COVID ward where you can install the technology in the return air grill so that you can protect the air going back into the central return air system and not have pathogen air that's mixing with other spaces. You can install these kind of systems in split type units as well. Again, these can be whether it's UV lights or ionization or non-thermal plasma. can be installed in fan coil units as well as easily. Again, all of the technologies can be done this way, and central station systems, as you see here. I like to talk about this because this is really critical. The Winter Olympics in 2022 happened to be in China, and the Tianjin airport, which moved a lot of people through there, did install non-thermal plasma. In this particular case, not only was it in the airport terminal, they had it in the train station because people flew in to the airport, then took the train, and they even had it installed within the train cars themselves. So this was just a general overview of number one, what's going on in ASHRAE. Number two, to kind of open your eyes up a little bit to the fact that, when we're talking about particles, particles are really important, and that's one of the reasons why ASHRAE is going to start increasing the MERV level within the next code cycle that's going to be coming down the pipeline. But more importantly, I wanted to talk to you about how some of these technologies offer you other types of benefits, as I said, such as particle agglomeration, and they do come with a payback as well. So at this point, I'd like to, and I apologize if I was speaking a little bit too fast, but I was trying to get it all in time, and I think I came in even earlier than I needed to. But at this point, I'd like to turn it over back to Lori to see if there were any questions that were being asked.
Yeah, thanks, Nick. That was super interesting. And I actually wanted to let everybody know, too, while you're entering your questions in, because we don't have any yet, that there will be an article in our winter issue on this very topic, and that will be coming out in January. So I just want to make sure everybody knew about that. And then I can kind of get the ball rolling, but I just want to remind you guys, you can ask your questions now in the pane that you have for Nick, or contact him. He left his contact information up there for you. So Nick, how is ASHRAE standard 241 going to be adopted?
Okay, thank you for that question. So one of the reasons why 241 is a standalone standard is because different states have adopted 62.1 or 62.2 at different levels. Like, for example, in New York City, they're not using the latest one. They're using, I believe, 2016 or 2018. I'm not sure. I can't remember the number that they have. So because of that, they're leaving it as a standalone standard so that everybody can adopt it regardless on what year they may be using as 62.1 or 62.2. However, both standards and 62 is under review as we speak, and they're adopting it as part of an addendum to their standards so that any year could adopt this thing moving forward. However, organizations like, of course, the U.S. government, the GSA have already started adopting 241. The VA hospitals have adopted 241. Some school I should say, schools in certain districts have already adopted 241 and are upgrading their systems to incorporate either ventilation or filtration, either way. So different people are going to be adopting it at different times, but it is a standalone feature for people that maybe want to consider using this thing independently to whatever 62.1 or 62.2 may be mandating. But it is going to be going out for public review, and as I say, both 62 standards are going to be incorporating it into their language following the next meeting in Orlando.
Okay, which is in February, right?
It is early February, yes.
February. Okay. We do have one question, and I'm not sure. Maybe you could respond to this or not. How do I know that the UV lights I'm installing in homes are effective?
That's a very, very good question. So when you're working with a UV light company, as I mentioned earlier, you have to look at the wattage of the UV light. And I can work with whoever's interested to reach out to me, and I can show them how to calculate that. But you need, as I mentioned earlier, an average of about 6 watts of power, which is going to require about 3 feet of intensity if it's at 500 feet per minute, or 6 feet of intensity if it's going to be in a duct system. If you don't have that, then to start off when it's brand new, it's never going to work. But the UV light company that you're working with will tell you what the degradation rate is going to be, meaning that they're going to tell you, look, you're going to lose 50% of your intensity after 24 months. And the only thing you can do is at that point say, okay, I'm going to change it out in 24 months. Or you might say, you might tell your customer, look, you might as well just change it out after 12 months if you want to be safe. But there are intensity sensors that can be purchased and installed so that it can give you some kind of indication as you get to a certain level. But from what I see, a lot of residential consumers may not want to flip the bill for something like that. So it's hard to determine whether it's working after it's been installed, let's say after 6 months. But if you want to know if it's working beforehand, again, it has to be designed correctly, and depending on the size of the bulb that you're putting in, will determine if you're going to get the immediate results moving forward. So you have to look at the wattage of your light, and as I say, you need 75 millijoules per centimeter squared, and I could convert that for whoever's interested offline. But without the preliminary design being correct, well, on day one, you're not going to be working. And again, the concern from a lot of physicians is that if you don't design it correctly, it's like they overprescribe antibiotics. You know, a person goes in, I got a nose infection. Okay, here's some Zithromax. I got an ear infection. Okay, here's some antibiotics. Oh, you know, my pinky toe hurts. Okay, here's some antibiotics. And so we've overprescribed it, and they've come back because all they've done, we'll never win the fight against viruses. Like humans will not. They've been around for billions of years, and they just constantly keep mutating to something that's stronger. So if you don't design your system correctly, all you've done, as I said earlier, is just pissed off the pathogen, and it's going to come back stronger. So again, I'm repeating myself. Number one, you need to make sure you're designing it correctly from day one and maintain those conditions. And if you are working with a UV company, then you should be getting them to give you exactly based on the size of your of the area you're moving or the size of your HVAC system. They'll tell you what wattage of bulbs you should be putting into there. If you're working with a distributor, then it's going to be incumbent on your distributor to tell you, okay, this is what they're recommending moving forward. But unless you install some kind of UV light sensor that can give you an indication, it's impossible to determine whether it's working or not, because the light is blue. It's always going to be blue, even when you're at 50% intensity. So it's difficult. You know, what's good about ionization or non-thermal plasma is that it's sustained efficiency. You don't get a degradation over time like you do with some of the UV lights. So that could be an alternative going either way for whoever raised that question. But again, if you want to reach out to me offline, my contact information is there, and we can do a little bit of a deep dive into some of the applications that you have.
That's great. Okay, pissing off pathogens would be a great article title. So another question is the negative effect, is there a negative effect for placing these high-end filters in air distribution systems that aren't designed for that?
Oh my gosh, absolutely. If so, you have a lot of people that say, okay, I'm going to install a MERV 13 filter in some of these older systems that are 10 years old, unlike the newer systems that are using EC fans as an example, where they can overcome the static pressure. But the problem is that, number one, what ends up happening is as you increase the static pressure drop within an HVAC system, if you can't handle that increased static pressure, whether it's the initial static pressure or dirty static pressure, you're going to lower the airflow. So these are the complications when you lower the airflow. Number one, you have a potential to freeze your coil during the cooling season conditions. Number two, if your airflow gets down so low, your heating might not come on because you don't have enough airflow. But more importantly, you're going to be straining your fan motor, and you're going to end up burning out your fan motors sooner than you should. And then finally, because of the reduced airflow, if let's say you're in the middle of the cooling season and you have less airflow, the calculation for cooling is Q is equal to a constant, whether you're talking about sensible or total, times your airflow times your delta T. So if your airflow goes down, then what ends up happening is you can have a lower delta T, but you could end up freezing your cooling coils. But as you lower your airflow, your total cooling capacity goes down. Your Q number, your BTUs per hour goes down. So your systems have to run longer, and it's going to cost you more money in air conditioning. So if you are going to install these types of advanced filters, you got to make sure you can overcome them. And as I say, a lot of residential systems can't handle it. And if they are going to install, if they want to stay with standard particulate or particle arrestance filters, like non-wovens as an example, then I recommend a partial bypass system that would have its own fan. So if you have 1200 CFM going through your return air duct, um, uh, upstream, you take out, let's say, 500 CFM, you give it some heavy purification through some HEPA filters, it's got its own fan, and dump that 500 CFM downstream of where you originally took that 500 CFM. So you don't need to filter the entire amount of 1200 CFM. You could filter only half of it over, or a portion of it, and that's labeled partial bypass filtration. And these systems, as I say, come with their own fans, so they can overcome the static pressure of these HEPA filters and yet still achieve the same type of end result filtration or quality, air quality within the space. They are expensive, that's for sure, but if you don't do that, as I say, there's a lot of issues that will percolate up in your HVAC system.
Good repair versus replace discussion with the homeowner, right?
Yes.
Okay, for small HVAC contractors, this topic seems a bit huge. Is there an area that can meet the standards for homeowners, and which product or products should we be looking at?
Uh, you mean for, I should ask the person, they can, I'll try to answer it, but are they talking about for pathogen or particulate control? Because a lot of distributors um, do
Both.
stock.
He said
Okay,
both.
for both. Well, a lot of, again, if you're going to look at particle control and you don't want to use some of these electronic systems, then you should not be putting in these high resistance filters into your standard residential HVAC unit. You should be looking at partial bypass, which means it has to have its own fan. But all the distribution companies, whoever you're working with, whether it's the Fergusons or I don't know where you may be, like Our Steel or GA Larson or Mingledorf, whatever it may be, they do stock a lot of these types of systems. In fact, almost all of them are stocked with these distributors. But again, if you're going to be installing them, don't just buy, as an example, if you're going to use UV light, don't just buy a UV light and put it in like that picture I have of that gentleman sliding in one small little UV light bulb and thinking it's going to work. It just has to be designed correctly. But if you do speak to the will counter people at these distribution companies, they should be able to reach out to whatever technology you might be interested in to give you the guidance that's needed. Otherwise, reaching out directly to those companies, whether it's like, as an example, I know a gentleman, his name is Aaron Engel over at UV Resources, not to mention that's just one name of many, like Atmosphere, and they usually will answer. They have technical service departments that will answer technical questions on applications before you buy. Same thing with Reviveaire. You can call Reviveaire and speak to somebody at technical support, and they'll help you. So you don't even, before you even go to buy these products at distribution or bid the spec reps, calling their technical support will give you the assistance that's needed.
That's a good response.
And
So this is a
again,
good question.
they can reach out to me and I'll be able to help them in whatever application they have, whether it's non-thermal plasma or anything else.
I
Sorry,
don't
go
know.
ahead.
I heard your upcoming travel schedule. That seems stressful. You're going to be busy.
Yeah.
Okay. When removing, this is good. When removing the MERV 8 or 13 filters, should we be concerned about how we handle them for disposal regarding
Oh
the
my God.
microparticles?
Okay, whoever brought that up Huge thank you. Huge thank
Good
you.
job.
Yes, 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 absolutely. In fact, now we realize that, as I mentioned in my presentation, and again, a huge thank you to that person who asked that question. Viruses don't die.
Mm,
Viruses aren't living. They're looking for a host. So because they don't die, like a bacteria that gets trapped in a particulate filter, like a HEPA filter, if it doesn't get food, it will die. That's DNA based. Anything that's RNA based, it just sits there waiting for somebody. And yes, I actually have a picture of this in another presentation where a person is handling a filter that's contaminated. And there is a huge amount of discussion right now within the committees at ASHRAE on servicing these filters. But absolutely, if you're, let's say, servicing a filter and it happens to be in a senior citizen's home or a daycare center, and there's a potential that, yes, the virus could be in there because people were infected, it's considered a biohazard. You have to be gowned up, you have to have the right gloves, you have to have eye protection, and you have to have respiratory protection as well. You can't handle those filters because they are potentially going to infect you if the virus is on that filter, without a doubt. And that's why so many people are moving away from standard particulate filters for the control of pathogens and saying, no, you need to use an electronic device. You need to disinfect. So you've got particulate filters that, yes, trap, but don't disinfect, which is why the Lincoln Center is saying, look, I don't want to go down to MERV 8. I want to keep my MERV 13A, put in a disinfection device and get both. So that if anything does pass if you're using UV lights as an example, and it gets trapped by the particulate filter, at least the UV light will illuminate onto the filter and ultimately kill the virus that may be trapped. But without a doubt, if you're going to be servicing these filters, you need to protect yourself. If you don't, you're going to be exposing yourself or your technicians to potentially something that's very harmful. So that's a great question, and it is a huge concern moving forward. We now realize that it's a problem, and we need to grade these applications based on the potential of risk for these technicians moving forward. But
yeah. And
again, if you're servicing in a hospital or in a clinic or any of these areas, absolutely must be gowned and protected accordingly.
and how do you dispose of them if that's the case, if you're in a hospital facility? What's proper disposal?
So in a hospital facility, they do have um, I guess, protocols in place in their dumpsters so that anything that's considered a biohazard will be incinerated. So the hospital itself, you can use their biohazard dumpsters because they go to a special location. Unfortunately, and again, when I give my presentation as the business, I talk about the benefits of no landfill, no waste, and no potential of harming the environment. Because again, a lot of times these filters end up in landfills, and these viruses just come back
Mm,
stronger, stronger, and stronger because as you dispose of them, they don't die. They're just always there.
yeah.
But there are proper depending on what state you're in. If you don't have the proper biohazard disposal protocols in hospitals, and you still need to do that, you have to speak to your local where your whatever controls the waste or garbage in that state, and ask them about the biohazard regulations, and then follow
The things
that.
we hold our techs responsible for, you never know these things till you're in the industry. One thing, another question we did receive, and I think this has to do with the partial bypass system you mentioned. In many systems, MERV 13 filters create too much static. What do I do in that case? Is that also to do with the partial bypass system?
So yes, there's two things you could do there. Either you install a partial bypass system, and you could make one yourself by buying a fan and with sheet metal, a box, and just have filter tracks that you put into there, and that's make sure. But there are companies out there that do have partial bypass systems that they sell. And otherwise, if they have an older system, then and they absolutely categorically, irrevocably say no, I want the MERV 16 filter, then it can't just be sold individually as a standalone system. It has to be sold with either upgrading the fan that's in their furnace or upgrading their entire furnace. It doesn't mean you have to change their cooling coil, but the furnace itself with the fan needs to be replaced, that with something that has EC technology that can overcome that static pressure. Otherwise, they're solving one problem and they're going to be creating a whole bunch of other problems uh, with the operation of the HVAC system.
And more
So it
callbacks.
has a fan upgrade as well.
Yeah. Okay, I think we got through all of that. Oh, hold on, one more. Oh, okay, that's a comment. Thanks, Paul. Paul, thanks for that great question too you had earlier. I believe we've answered all of them, so I'm going to take control back if that's possible. Sometimes my system gets a little stuck. Just so everybody knows, I will be posting this to the archives probably tomorrow or Friday. Everybody who's attended the live session will receive 1 hour of continuing education. You should receive a certificate as soon as I end this program. And if you're an RSES member, you have access to all of our archives. You just have to log in first. I was going to show that to you, but my system is not letting me right now. So I'm just going to go ahead and wrap it up. And Nick, thank you so much. That was so much information. We really appreciate it. And don't forget to read the article that'll be coming out in January on the same topic, everybody. Have a great night.
Thank you for all the questions.
Yes, thanks everybody. Have a great one. Bye-bye.
Bye.